So I apologize for doing that, for cutting it out. But there's actually a time limit on some of these videos. So for the program I'm using. So let's get back to it. We are going to discuss light deflection and gravitational lensing. So light is bent by a massive object, which results in our perceived image of light coming from the same source. So a star that is long gone can still have light that reaches you because the light is traveling at a fixed speed, but also because there are spherical objects in the path of the light is going to be bent by the gravity, the mass of those astronomically large objects. And thus, we may get an idea that there is a source behind that astronomical object permeating that light, when in fact it is just a reflection of light from an object that is gone. That's just an example. Then, of course, you have gravitational time dilation. So time runs slower as it gets closer and closer to a gravitating body, which kind of makes you think how time travels in the void of space where there is no gravity acting on any astronomical object. If there's just plain void, what's actually going on with time? Our perception of time, at least. Because if the entropy of the universe does go at a fixed direction where entropy is increasing and thus time cannot be reversed, what's going on when there's no gravity there to influence that? And then we have gravitational waves. So massive bodies like a rock in a pond can cause ripples, but instead of a pond, it's space-time. So space-time does have some form of fabric that can be rippled. Gravitational waves also travel at the speed of light. Isn't that interesting enough that light and gravity both travel at the same rate? So when two objects orbit around one another, they emit gravitational waves, expelling more and more energy as they get closer. And the force of gravity is inversely proportional to the square of the distance. So gravity and gravitons have this amazing influence, very, very much similar to how light is bent. Gravity does the bending, which is pretty cool. They have yet to be truly detected, though, because gravity and thus gravitons, their particle constituent, is so weak and minute. And of course, with the fabric of space-time, because of mass bending space and mass governing motion, which governs perception and entropy of time, space and time are in fact one in the same. All that ever was or ever will be exist in space and thus also in time. So think of it as the fabric of space-time being some sort of giant memory log. We can't go back in time with our memories, but they are still experienced. So because space and time are one and the same, massive bodies, gravity, push or pull space apart, affecting the direction of time speed and thus how it is perceived relatively. Denser gravity means a slower perception of time because motion is slowed down. Black holes are a very interesting concept when it comes to gravity and time and light. It's a great anomaly in space. Black holes are the result of massive stars imploding in on themselves and producing a rupture in space-time. The gravity of a black hole is so dense that in order to actually escape the event horizon, the surface of a black hole, one must travel faster than the speed of light. Gravity, which also travels at the speed of light, at least when it ripples, is a stable rupture in space-time, has the capacity to dilate the perception of time. Most black holes are actually inert, and their influence is really only felt when you're actually on the event horizon, if you don't die, where its entropy is the greatest, but not in its volume, its surface area. So how does this affect entropy, and what does this say about the fact of space-time? If time in the event horizon of a black hole is also theorized to be cyclic, this means that time is both forward and backward. Thus, it's somehow tapping into this cosmic memory bank within space-time where outside of a black hole, time is in one direction, but at the heart of it, in the surface area of it, time could be so slow or so anomalous that it is going forward and backward. Cool. And we have also something called quantum entanglement that deals with space-time. It basically states that two particles that are separated by a significant distance can experience the same state of being in an instant. So if one particle changes at the end of the universe, so does another within that same moment. And how can this be explained if nothing travels faster than the speed of light? It turns out space-time fabric does. And remember, black holes can take in light because light cannot escape at the speed that it already is available. The fabric that constitutes the universe, the universal platform, travels faster than the speed of light via its expansion. So this explains kind of why space and time are being one and the same as it stretches. All that remains in the fabric, but still moves forward through motion and mass. The black hole anomalous ability to bend time, absorb light, and yet remain relatively inert as space-time itself is not entirely visible to us in how it functions. And this is just something I kind of theorize based on what I've read. So, for example, if a black hole dilates time, absorbs light via its intense gravity, light and gravity could be two of the same coin. Sort of how electromagnetism is both magnetism and electricity, just different functions of the same field. They both enable interactions. One of the visible universe being light of this dimension, the other being gravity, holds space and time together and apart, whereas light would govern our perception of time as well, how it can change. But is space 2D, or is it 3D? How if mass makes space 3D, if light can travel via being bent by gravity or just travel on a two-dimensional plane in and of itself, a 2D dominated stable inert black hole, because black holes are governed by surface area, which is two-dimensional, they rip in time. Does this explain what constitutes the way space-time behaves? So if you can reverse entropy exposed to the stored time of all the cosmic threads, could you reverse time? Could you reverse entropy? Photons and gravitons also both have zero mass. But what does that say about their equal but opposite attributes? Are they the same thing? I kind of think they are, in my opinion. I'm not a physicist. This is just what I'm reading and the theories I'm coming up with. They have equal and opposite attributes that both contribute to the cosmic manifold. Both in extreme streams of motion and mass can affect our perception of time, and with light, it is speed typically that affects us, and thus outside of entropy or within our own entropy. So that is my take on space-time. It's a very dense subject, so I can understand if it was confusing. That's why I didn't try to include math so much, but I like to think of space-time as like a big memory storage, or maybe like a big brain in and of itself, or you can cut up a brain in any way you want. You won't have direct access to the memories in that particular brain. It can only really be experienced. Kind of like how a black hole experiences so many anomalous perceptions of light and time and gravity. And it's just,